So this video, we're going to show you a multitude of different physical properties kind of all rolled into one. And so I'm going to start with color. So you would think that this would be a really easy diagnostic way of identifying a mineral. But the problem with color is that it's not reliable unless you have a mineral that only comes every single time in one color and one color only. If you think of quartz, it's a good example. Quartz has amethyst, which is purple, smoky, which is gray. You have citrine, which is orange. You have milky, which is white. And it comes in so many different colors that the color of quartz is not a very diagnostic way to identify it. And so there are certain minerals that you can actually use color because they are always going to be the same color. And so let me show you 4 examples of where you can use color as an identifying property. So starting with this lower corner, this is kyanite, and that is the main ore for spark plugs. There's a good ore. This is actually aluminous. So there's aluminum in there, and that's what they use that for. And that's always going to be that really nice shade of blue. Okay, next we have rhodochrosite, and that is going to be always this pink color. It might vary in shades of darker pink, lighter pink, but it's very distinctive in that pink shade, and we can identify it. And the next color, the next mineral, I'm sure you guys are familiar with azurite, which is a copper ore. And azurite is always going to be this beautiful shade of dark royal blue. And you, more than likely, when you see azurite, you'll see malachite accompanying it. And malachite is always going to be this green. So when it comes to minerals that don't change its color, then it's okay to use color. But once again, just remember that when you're dealing with most minerals, color is not a very good diagnostic tool. And so then we move on to this next artboard here. And these are some of the other physical properties that you can use to help identify your mineral. Such as the first one here, some minerals have magnetic properties. And so they contain magnetism. And so we know that we can identify, if you remember earlier, we did the metallic minerals with the streak, and we had these 3 minerals together. And this one was red, this one was gray, and then this one was the pencil. Well, so this one here, oh, I know now I have magnetite because it didn't streak red, it streaked gray, and it's magnetic. So it's a very useful identifying property, especially with these dark metallic minerals, since there's so many of them. So there's a list of all these magnetic minerals, and if it matches all the other physical properties, then it's an identifying factor. And I wish I could scratch this and give it to you guys to sniff, but this is sulfur. You guys can just imagine how disgusting it smells. It smells like a cross between a rotten egg and a fart. So I probably don't need to have you guys smell that. We're gonna come over here, and physical property is taste, I'm sorry. And so you get a lot of minerals that are clear like this. They're see-through, and they look like every other mineral. And so, you should be glad you're not in a face-to-face class, because I would ask somebody to volunteer and lick the salt, which I guess I'll do. And so I taste that it's salty. And so that's a very good distinguishing identifier for halite. Okay, and then last we have what's called fizz. And so this is going to come in really handy, you guys, especially when we deal with sedimentary rocks. Okay, certain chemicals will react with acid, and so calcium carbonate is the one that usually reacts. And us geologists, we always carry around a little bottle of hydrochloric acid. And so what that hydrochloric acid does is when you put it on a rock and it fizzes or reacts, we can identify that as a carbonate. A carbonate, which has a chemical composition of it's a calcium and 1 carbon, 3 oxygen. And that is a carbonate. And the most common mineral is calcite, and the most common rock is limestone. Okay, that's something that you guys should tack into your little file card in your brain, because what happens is when you're out there looking at a lot of sedimentary rocks and they all start to look alike, this can help you decide whether or not you have a limestone versus a shale or a clay. And so if you take a look, let me get the light shining on this so that you can get a really good idea of what it is I'm talking about. I'm gonna go ahead and, do you see that reaction? That is the calcium carbonate reacting with the hydrochloric acid, and it's creating vapor, it's creating gases, and it's eating away, and it's creating carbonic acid. Okay, and when we go into sedimentary rocks, we'll go into the breakdown a little bit more on how the chemical reaction is between that. So if I'm out and about and I want to know if I have, I'll just dribble a little bit, and if it fizzes, I know that I have a carbonate rock or a carbonate mineral, which is calcite. Okay, and so that is also another useful physical property. And so these are the most common physical properties with this video and the videos that you've seen before. And we will be using all of these different physical properties to identify the minerals that you purchased in your rock kits. And that's it.